So since we're simply talking about household electricity, let's now consider here another application of household electricity other than how are you going to pay the Meralco bill. We are now going to consider here the electrical safety part of our discussion. So on the very first part of your module, there are actually 10 tips that you might want to reconsider whenever you're handling electricity at home for your safety and for the safety of the people that is surrounding you. Now, in the case of electrical safety, there are actually different types of devices that is present in our household that will actually help us avoid any types of accidents when it comes to the use of electricity. So we have here the presence of the following. The first one from right, we have here the presence of different types of fuses. Then at the center, this is now the presence of a circuit breaker. And lastly, we have here the presence of a grounding system. And now, since we are talking about electrical safety, let's have another application of electrical safety when it comes to the concept of the things that we had discussed earlier regarding the presence of electrical power. Now, on page number 4 of our module, our first problem, will a 1200 watt oven operate on a 120 volt extension cord if the current is limited to 15 amperes by a safety fuse? Now let's consider the GRESA for this particular type of problem. Let's simply start with the given. According to this particular problem, the power that is present on an oven is equivalent to 1200 watts. Then the next one, the current, it is equivalent to 15 amperes. And when it comes to this particular type of amperage, it is now equivalent, it is now present on the fuse. Then lastly, the voltage, it is now equivalent to 120 volts. Now, for the required, the question here, will it operate? Then, for our equation, we are just going to check if the amount of power will simply suffice the voltage and the current. We have here the formula, which is power is equivalent to voltage times current. Then, for our solution, in this case, we're actually going to check if the power will exceed 1200 watts. Because if the power will exceed 1200 watts, that certain type of appliance will work in this certain type of extension cord. If it is lower than that amount, it will not work on that certain type of extension cord. Okay, so we are just checking. If the value is higher, that certain type of appliance will work. But if the value is lower, that appliance won't work. Okay, the oven won't work. Then, when it comes to this certain type of solution, once again, we have the amount of voltage which is equivalent to 120 volts. Then we're going to multiply it with 15 amperes, which will simply give us the answer that the power that the extension cord can have is equivalent to 1800 watts. Okay? Since the amount of power that can be handled by the extension cord is definitely higher than the consumption that is needed by the oven, it will now be utilized. Let's now proceed to the second part of the problem. Now, the question here, if two ovens will be placed in the same extension cord, will overloading happen? Okay, so if we're going to consider now overloading, the amount of power is too much for the cord to handle. If the electric power will be too much for that certain type of extension cord to handle, there is actually a possibility that it will burst into flame and short circuit will probably happen, or it might result to fire. Once again, the given for this particular problem, power, which is equivalent to 1200 watts. Okay, we are simply considering here the power that is present in this particular oven. For us to get the required, we are now going to consider if will the fuse be busted, or will the fuse melt if there will be the presence of two ovens that is connected in this extension cord. Okay, remember, if you're now going to consider here the amount of power that can be acquired in this certain type of fuse, we are going to use this for us to check our answer. The power that can be supplied in the fuse is equivalent to 1800 watts. The value of the total power will exceed 1,800 watts, your fuse will be busted, okay, or your fuse will melt. So now let's get the total power, and it's equivalent to power 1 plus power 2. Since we are talking about here 2 ovens, it will now be equivalent to 1,200 watts plus 1,200 watts, which will simply give us the total of 2,400 watts. And as you can observe, the total amount of power that will simply be exerted by 2 ovens exceeds the power that can be utilized or that can pass through that certain type of fuse. So technically, the fuse will melt if 2 ovens will be utilized in this certain type of setup. So that's the thing about electrical safety. We are now simply considering here if the amount of electricity will exceed, or if the amount of electric power will exceed, the fuse will technically be busted or it will melt. So in that case, on page number 5 of our module, Practice Makes Permanent, once again, just analyze the problem that is present and answer once again on page number 9 the problem that is present on this page.